talk about geodetic applications of satellite altimetry. The geodetic application. You know that the first goal of geodesy is to determine the shape and size of the Earth, and the physical shape of the Earth with the approximation of 72%, about 70% is the sea level, because 72% of the Earth is water, it's covered by water. So the main goal, the first goal of this is to determine the geoid surface for the Earth, over the oceanic area. So I wrote the equation that geoid will be sea surface height minus sea surface topography, or the dynamic topography. It comes from oceanographic model, models, and subtracted from SSH to get N. The geoid can be computed directly from SSH. So that's the geoid, we call marine geoid. So based on this marine geoid, from this marine geoid that we have determined point by point over ocean, we can also compute deflections of vertical. If you remember in physical geodesy, deflections of vertical, which are C and eta, are computed by this 4pg gamma integral Stokes integral over the year, and delta G, which is gravity anomaly, and this is derivative of Stokes function multiplied by cosine alpha sine alpha. Yeah, which is the Stokes function, and this is derivative of the Stokes function actually. So this part, this gravity, if we have gravity anomaly, we can come to that, but we do not have the gravity anomaly. We have the geoid. What can we do with that? So already we know that the deflection of vertical is the slope of the geoid with respect to ellipsoid. So I can say that, okay, this is the derivative of geoid with respect to phi, r phi, and eta is the east-west component of deflection, is the derivative of geoid, cosine phi, sine, and derivative with respect to lambda. So how can we compute that one? So over an area we have let's say I have an area, and this is the ground track, and the ground track, they have the azimuth. So if I have a point here, and I have the, let's say, geoid here, I can take the derivative. First of all, I should compute this. I should compute the geoid here over this area. Let me draw it again. So if I have a geoid here, I need derivative in that direction. So simply, I have this alpha, this is satellite track azimuth, and also satellite track azimuth. Then I can determine this by, let me see. If I have the geoid, I can compute it. Okay, I can say derivative of geoid with respect to will be derivative of geoid with respect to, for example, another quantity. You see this distance, for example, psi, derivative of psi with respect to alpha, or not, there is a psi with respect to phi. So derivative of geoid along this curve that can be simply computed numerically. So if we have a small distance here, I can compute the rate of change of the geoid with respect to psi. That's fine, we can compute it. It's the slope of geoid. Then I have the psi. Then I can, psi has a mathematical model. We can write it, equation for psi based on the geometry of spherical geometry. Let me write it there. If you have a sphere like this, and I have one point here, of course, this triangle is too big, of course, but it could be an approximation. So this is alpha, and it will be 90 minus phi, and here will be 90 minus phi 2, and this will be lambda 2 minus lambda 1. Because you know cosine psi will be sine phi1 sine phi2 plus cosine phi1 cosine phi2 cosine lambda 2 minus lambda 1. So, and you need the derivative with respect to phi. For example, phi 1 and exactly phi 1. So you can take that. Okay, you can write. Okay, derivative of psi with respect to phi will be derivative of cosine psi with respect to phi. Derivative of the psi with respect to psi instead of phi. The derivative of cosine with respect to psi. No. Derivative of sine, cosine. Cosine. Derivative of cosine with respect to psi, then derivative of psi with respect to phi. Let's come to the same thing. No, it doesn't. Or simply, if I solve psi, the cosine inverse sine phi sine phi 2 plus phi 1 cosine phi 2 cosine lambda 2 and lambda 1 cosine of the phi. It should be cosine alpha. So you can compute this term. Therefore, you can simply derive the derivative of the, you wanted to compute derivative of n with respect to phi. But you have n in along the track. Then I said it will be derivative of n with respect to psi. Then you can compute it with interpolation. Derivative of psi with respect to phi. Then you can get this. And this one is with the cosine. Compute the derivative with respect to psi, along the sine, and then is cosine alpha. So based on this equation, similarly for n, it will be lambda, which will be cosine phi. It will be sine. alpha. Then you can compute the deflections of vertical directly from the geoid. So now the question is how to determine gravity anomaly, for example. If I have n, it means that I have SSH, I have removed SST from it, then I have this integral, which is well known as Stokes integral, as you know. Then I will solve this integral reversely. It means that I consider delta G as unknown and n as known. So I have an observation equation here, and this integral can be written in a summation form. For example, I to j and delta gi and sij and j, si, not j, sik, for example, in k. Then you can have this observation equation and you can solve it by this discourse. Of course, this integral will be, if you solve this integral, it will be condition and you have to apply regularization to solve it. And similarly, you can get the gravity anomaly from the deflections of vertical. So now assume that I have computed the deflections of vertical from the geoid directly and the marine geoid. Just simply I can write this is an integral and plus again gravity anomaly. This is derivative of a Stokes function with respect to psi, and this is derivative of psi with respect to phi, and this is derivative, this is alpha, and this is sinus. Then again you have an integral equation. Here you have unknowns, and here are nouns. You can solve discretize this integral and solve it by numerically by regularization method to get gravity anomaly. Of course, in physical geodesy, we could solve this in another form. We can make another kernel for determining this, this gravity anomaly from this point, and it will be involved with vector spherical harmonics, but this is not the subject for this course now. We have already discussed this in physical geodesy.